What if everything you have ever seen is not real? The sky above you, the ground beneath your feet, the people you love, the memories inside your mind, even the body you call you. What if all of it is part of something far stranger? A system, a structure, a program. Not a simple video game, not a cartoon world, but a simulation so advanced, so detailed, and so perfectly designed that nobody inside it could ever prove it was fake. For most of human history, this idea would have sounded insane. But today, some of the smartest people in the world have taken it seriously. Scientists, philosophers, physicists, and computer engineers have all asked the same disturbing question. Are we living in base reality? Or are we living inside a simulation? And the strange thing is, the more we study the universe, the more it starts to look like something that has rules, limits, code, optimization, and maybe even hidden shortcuts. So let's ask the question directly. What are the chances that our universe is simulated? The honest answer is, nobody knows. There is no experiment today that can prove, with certainty, that we live in a simulation. But there is one argument that made this idea famous. It comes from philosopher Nick Bostrom. His argument is simple, but terrifying. Imagine that one day, human civilization becomes extremely advanced. Not just a little more advanced than today, millions of years ahead. Imagine that future humans, or some other advanced civilization, develop computers so powerful that they can simulate entire worlds. Not just cities, not just planets, but entire conscious beings. People who think, people who feel, people who believe they are real. Now imagine that such a civilization could run not one simulation, but billions of them. They could simulate ancient Earth. They could simulate different versions of history. They could simulate entire universes. If that is possible, then there could be billions, trillions, or even more simulated realities. And only one original reality. So statistically, if there are many more simulated minds than original minds, then maybe the odds are higher that we are inside one of the simulations. This does not prove we are simulated, but it does make the possibility much harder to ignore. Because if advanced civilizations can create realistic simulations, and if they choose to create many of them, then most conscious beings would not live in the original universe. They would live inside a copy. And that leads to the first strange clue. The universe seems almost too perfectly tuned. Look around you. Stars exist, planets exist, atoms exist, chemistry exists, life exists, and eventually conscious beings appeared who could look back at the universe and ask why any of this exists at all. But this only happened because the universe has very specific values. The speed of light, the strength of gravity, the electromagnetic force, the strong nuclear force, the mass of particles, the behavior of atoms. These are not random details. They are the basic settings of reality. And if some of these values were even slightly different, the universe might be completely dead. If gravity were much stronger, stars could burn too fast, or the universe might collapse. If gravity were much weaker, matter might never gather into stars and galaxies. If the electromagnetic force were different, chemistry might not work. If the nuclear forces were different, atoms might not form properly. No stars, no planets, no water, no biology, no us. It is almost as if the universe began with a perfect configuration file, a set of parameters, like the settings inside a game engine. In a video game, the developer decides the rules, how fast light moves, how gravity works, how objects interact, what the boundaries are, what can happen, what cannot happen. In our universe, we also have rules, extremely precise rules, and they apply everywhere. A particle on Earth follows the same basic laws as a particle in a galaxy billions of light years away. That alone is strange. The universe is massive beyond imagination, and yet it behaves consistently, as if there is one underlying system running everything. Of course, this does not mean the universe is literally computer code, but it does raise a deeper question. Why is reality so mathematical? Why can we describe planets, light, gravity, electricity, atoms, and black holes using equations? Why does mathematics, something that seems to come from the human mind, describe the physical world so perfectly? Some people say this is because mathematics is simply the language we use to describe patterns. But others wonder if mathematics works so well because reality itself is built from information, from rules, from something very close to code. And then we find something even stranger. At the smallest scales of reality, the universe does not behave like solid matter. It behaves like probability. This is where quantum physics enters the story, and one of the most famous experiments in science is the double-slit experiment. Imagine firing tiny particles, like electrons, at a wall with two narrow openings. Behind the wall is a screen. If particles were simple little balls, you would expect them to pass through one slit or the other and create two lines on the screen. But that is not what happens. When nobody measures which slit the particle goes through, the particles create an interference pattern, a pattern you would expect from waves. It is as if each particle goes through both slits at once, spreading out like a wave of possibilities. But when scientists measure which slit the particle passes through, the pattern changes. The particle behaves more like a single object. The act of measurement changes what we see. This does not mean human consciousness magically creates reality. That is an exaggeration. But it does mean something deeply strange. When information about a quantum system is measured, the behavior of that system changes. Before measurement, reality seems to exist as a field of possibilities. After measurement, one outcome appears. Now think about how modern video games work. A game does not render the entire world in full detail at all times. That would waste too much processing power. Instead, the game renders what the player can see. Objects far away may be simplified. Areas outside the player's view may not be fully loaded. Details appear when needed. This is called optimization. The system saves resources by only processing what matters at the moment, and quantum physics feels disturbingly similar. Not identical, but similar enough to make people wonder. Does the universe fully render reality only when interaction or measurement happens? Is the world around us always fully defined? Or does it exist as probability until information is required? Again, this does not prove simulation, but it makes reality feel less like a solid machine and more like a system based on information. And if the universe is a system, then maybe it also has limits. Every game has limits. Every computer has limits. Every program has rules that cannot be broken. And in our universe, one of the biggest limits is the speed of light. Nothing with mass can reach the speed of light. This is not just because we do not have powerful enough rockets. It is a fundamental rule of physics. As an object with mass moves faster and faster, it requires more and more energy to keep accelerating. The closer it gets to the speed of light, the more energy it needs. To actually reach the speed of light, it would require infinite energy, and infinite energy is not physically possible, so the speed of light acts like the maximum speed limit of the universe. But this limit is even stranger than it sounds, because speed is connected to time. According to Einstein's theory of relativity, time is not the same for everyone. Time can slow down. The faster you move relative to someone else, the slower your clock runs compared to theirs. And that idea is deeply unsettling. It almost feels as if the universe is constantly balancing two connected quantities. As speed increases, time slows down. As speed decreases, time speeds up relative to a faster observer. It is as though reality is shifting something from one side of the equation to the other. When one value approaches its maximum, the other approaches its minimum, almost like a perfectly optimized system trying to preserve a deeper rule hidden underneath. And this is not science fiction. This is real physics. It has been tested repeatedly. Even GPS satellites must constantly correct for tiny differences in the flow of time. Without those corrections, GPS navigation would quickly become inaccurate, but things become even stranger. Imagine a journey to a star located 10 light years away. Most people think about that trip in a very intuitive way. If you travel at nearly the speed of light, then surely the journey should take nearly 10 years. And from Earth's perspective, that is largely true. Observers watching from Earth would see years pass during the trip. But the traveler experiences something completely different. As the ship approaches the speed of light, time inside the ship slows dramatically. The closer the ship gets to light speed, the more extreme this effect becomes. For the people on Earth, years may pass. For the traveler, only months may pass, or weeks, or perhaps even less. The distance itself begins to contract from the traveler's point of view. The universe almost seems to fold inward around the direction of motion. This is one of the strangest predictions ever made by physics. The faster you move through space, the less time you experience. A journey that appears enormous to the outside world can feel astonishingly short to the person making it. In a sense, the traveler is moving into the future, not through magic, not through a wormhole, but simply because time itself behaves differently at extreme speeds. Now imagine taking this idea to an almost impossible scale. Let's say that one day, humanity develops the technology to travel at speeds incredibly close to the speed of light. And let's say we decide to travel to Andromeda, our nearest major galactic neighbor. Located approximately 2.5 million light years away, Andromeda is the closest large galaxy to our own. At first glance, such a journey seems completely impossible. After all, even light itself would need about 2.5 million years to make the trip. But near the speed of light, reality begins to behave in ways that defy common sense. How could a journey across 2.5 million light years take only a single human lifetime? The answer lies in one of the strangest consequences of Einstein's theory of relativity. As an object moves closer and closer to the speed of light, time begins to slow down for the traveler. The effect is so extreme that a voyage which would take millions of years from Earth's perspective could feel dramatically shorter for those on board. The numbers are difficult to comprehend, but they reveal just how different reality becomes near the ultimate speed limit of the universe. To truly understand how strange this becomes, look at the table below. On the left is the time experienced by observers on Earth. In the middle is the time experienced by the travelers themselves. And on the right is the speed required to make such a journey possible. What makes this almost impossible to process is how violently the traveler's experience changes as the speed gets closer to light itself. A tiny increase in speed, less than 1%, can reduce the time experienced on board by hundreds of thousands of years. For the passengers, that difference could transform the journey from something impossible into something that fits inside a single human lifetime. But for observers on Earth, almost nothing changes. From Earth's perspective, the trip still takes about 2.5 million years. The ship leaves. Millions of years pass. Galaxies move. Stars die. Civilizations rise, evolve, and disappear. And then, to the people on board, perhaps only a few years later, the ship arrives. Imagine what that would feel like. To step onto a spacecraft knowing that, for you, the journey may last only a year. But for everyone you leave behind, 2.5 million years will pass. Your family, your friends, your entire civilization. Everything you have ever known would not simply be gone. It would have been gone for longer than human civilization has existed. That is what makes relativistic travel so unsettling. It does not just move you through space. It separates you from time itself. But even this is not the final layer of the mystery. At the ultimate limit, we find light itself. A photon crossing space does not experience time in the way we do. Strictly speaking, physics does not allow us to describe a true point of view for a photon. A photon does not have a valid reference frame in the same way that a planet, a spacecraft, or a human observer does. But as close as our equations allow us to approach that limit, the journey has no duration. From our perspective, sunlight takes about 8 minutes to reach Earth. Light from distant galaxies can travel for billions of years before reaching our eyes. A photon may be born inside a star so far away that its light crosses unimaginable stretches of space before finally striking a cell in your retina. From our point of view, that journey may take billions of years of distance, billions of years of cosmic history. During that time, civilizations could rise and fall. Stars could be born and die. Galaxies could collide. But at the boundary where light exists, time behaves in a way that almost breaks human intuition. The moment the photon is emitted by that distant star, and the moment it reaches your eye, become almost the same event, not separated by billions of years of experienced time, but compressed into something that, mathematically, approaches zero duration. It is as if, for light, the entire universe between the star and your retina is not a long journey. It is a single connection, a single event stretched across space from our perspective, but collapsed into almost no time at the edge of physics. That idea is nearly impossible to visualize, and yet it is one of the strangest consequences of living in a universe where time and space are not fixed. They bend, they stretch, they contract, and at the speed of light, time itself seems to disappear. And perhaps the strangest part of all is this: the equations do not forbid us from getting closer and closer to the speed of light, but they do forbid an object with mass from ever reaching it completely. The barrier to approaching the limit is technological. The barrier to reaching the limit is built into physics itself. We do not currently know how to build engines capable of reaching such extreme speeds. But even if we did, the final step would remain impossible, almost as if the universe is showing us the edge of the system, while keeping it forever out of reach. Astronauts already experience tiny amounts of time dilation. Particles moving close to the speed of light also live longer than they should from our perspective. The effect is real. The only reason we do not use it to jump thousands of years into the future is because we cannot yet travel anywhere near the speed of light. The energy required is far beyond our technology, but the rule is there. The universe allows travel into the future. It just makes it extremely difficult. And that is exactly what a well-designed system might do. It allows strange things in theory, but it prevents easy access in practice. The universe seems full of these boundaries. You can approach the speed of light, but never reach it. You can look back in time by looking into space. Because light from distant stars took years to reach you, you can observe black holes where time itself becomes distorted. You can study quantum particles, where reality behaves like probability. But every time you get close to the edge, the universe hides something. Inside a black hole, information seems trapped. At the Big Bang, our equations break. At the Planck scale, space and time may stop making sense. It is as if reality has a resolution limit. In a digital image, if you zoom in far enough, you eventually reach pixels. In a video game, if you inspect the world too closely, you eventually find shortcuts, approximations, invisible walls, or limits. In our universe, there is something called the Planck length. It is not necessarily a literal pixel of space, but it is a scale so incredibly tiny that below it, our current understanding of physics stops working in a normal way. It may represent a kind of fundamental limit to meaningful measurement, a smallest useful scale, a boundary where the smooth world we experience might give way to something deeper, something more basic, something informational. When you combine all these clues, the universe starts to look suspiciously optimized. It has constants that allow complexity. It has a maximum speed limit. It has quantum behavior that depends on measurement. It has mathematical rules everywhere. It has limits to observation. It has strange boundaries where our models collapse. It creates galaxies, stars, planets, life, brains, and consciousness from simple underlying laws. That sounds very much like elegant code, not messy code, not random code, beautiful code, efficient code, the kind of code written by something far beyond us. But we have to be careful. There is a dangerous trap here. Just because the universe looks like a simulation does not mean it is one. Ancient people looked at lightning and thought it came from gods. People looked at the movement of planets and thought Earth must be the center of everything. Humans are very good at seeing patterns. Sometimes we find real patterns, sometimes we invent them. So the simulation hypothesis may be true, or it may be a modern myth, a story created by a civilization that invented computers and then began to imagine the entire universe as a computer. Maybe every age describes reality using its most advanced technology. Ancient people imagined the universe as a kingdom ruled by gods. The mechanical age imagined it as a clock. The computer age imagines it as a simulation. So maybe the simulation theory tells us more about ourselves than about the universe. But even if that is true, the question remains, why does the universe behave in a way that makes the simulation idea possible? Why is reality mathematical? Why does information seem so fundamental? Why does observation matter in quantum physics? Why is there a cosmic speed limit? Why can time slow down? Why are the laws of nature so consistent? Why does the universe allow conscious beings to exist at all? Maybe we are not inside a computer. Maybe the universe is not running on hardware. Maybe there is no programmer. Maybe reality is simply much stranger than our minds can understand. But maybe, just maybe, the reason the universe feels like a program is because it is one. And if that is true, then the next question is even more disturbing. Who built it? Was it a future version of humanity? Was it an alien civilization? Was it something outside space and time completely? Or is our universe only one layer in an infinite chain of simulations? A simulation inside a simulation, inside another simulation, inside another. And if we ever create conscious simulated worlds ourselves, would the beings inside them ask the same questions? Would they look at their universe and wonder why their physics is so perfect? Would they discover limits in their reality? Would they find strange quantum rules? Would they ask whether their world was real? And would they ever be able to find out? Maybe that is the most terrifying part. If a simulation is perfect, the beings inside it may never prove it. Every experiment they perform would be part of the simulation. Every law they discover would be a law inside the system. Every telescope, microscope, equation, and thought would exist inside the same reality they are trying to escape. A character in a video game cannot look outside the screen, unless the developer allows it. So if our universe is a simulation, we may never find the edge. We may never see the code. We may never meet the creator, but we can notice the clues, the precision, the limits, the mathematics, the strange behavior of particles, the flexibility of time, the boundaries of space, and the fact that reality, when examined deeply enough, stops feeling like solid matter and starts feeling like information. We like to think that we understand the world around us. We build cities. We send spacecraft into space. We split atoms. We write equations that can predict the motion of entire galaxies. And yet, beneath all of our knowledge lies a disturbing truth. We do not know why anything exists at all. We do not know where the laws of physics come from. We do not know why the fundamental constants of the universe have the values they do. We do not know what consciousness truly is. We do not know whether time is fundamental or merely an illusion. And we do not know what happened before the Big Bang, if that question even makes sense. For all our scientific achievements, we still find ourselves standing before the greatest mystery of all. Why is there something instead of nothing? So are we living in a simulation? The answer is still unknown. But maybe the real mystery is not whether the universe is simulated. Maybe the real mystery is why the universe behaves so much like something that could be simulated. Maybe reality is real. Maybe reality is code. Or maybe reality is something far beyond both of those ideas. Something we do not yet have the language to describe. But one thing is certain. The universe is not as simple as it looks. And the more we understand it, the less real it seems. If we are living inside a simulation, would we ever be able to prove it? Let me know what you think in the comments. And if you enjoy exploring mysteries like this, consider subscribing. Because in the next video, we'll tackle another question that might completely change the way you see reality.